for those of you still here, have you ever seen one of those new Apple launches? You know, I'm a bit of an Apple fan, and then you used to have Steve Jobs and walking over, and then you have the one more thing moment. And then after that one more thing moment, so the day after, you get these sexy movies, usually with their chief designer, like Johnny Ive, and talking about how the new MacBook Air revolutionizes a new brushed stainless steel and high-tech laser cutting technologies and the greatest, fanciest products ever. Have you ever seen one of those movies? Put your hand up if you have. Okay, so they're kind of funky to watch, and you actually feel that, oh, it's about, you know, the metal of a new iPhone or iPad or MacBook Pro or whatever. You actually think it's cool, simply because how they're telling it. And of course, that British accent of Johnny Ive works as well. Now, I found another one, which is a bit of a parody on the Apple videos, but just to make it a little bit playful, let's see if this works. So I'm going to try to put this up. It's the launch of another new high-tech product.
We wanted to design and build an incredible mobile product, but without compromise. Everything that we learned designing really sharp scissors, and everything that we learned designing really small clippers, culminates in the new Nail Clipper Air.
Sometimes when you walk away from a new technology, it can lead to a breakthrough. And that's what we've done with the Nail Clipper Air. We've designed it completely around simple mechanical technology. And that allowed us to give our customers a product that is constantly on mode, with infinite battery life, so small, thin and light, and silver. All this happened because we had the courage to say that we were going to make a product that trims nails.
Decaf Frappuccino, thanks. We've done all this with an amazingly thin and light design. The 2-inch Nail Clip Air weighs just 0.5 pounds and measures 0.3 inches in the rear. And then it tapers to just 0.11 inches at the front. And for the first time ever, we've made a 1-inch Nail Clip Air. It's just as thin, but it weighs just 0.3 pounds. These are the lightest and thinnest nail clippers we've ever made.
While it is really challenging to design something that is so thin and so light, it's really hard to design something that is also strong, robust, and is precise. It's not only thin and light, but also has incredible structural integrity. There is something about how truly simple the parts are, inside and out, that makes this, I believe, the most beautiful product we've ever designed.
We set a really high bar for what people should expect with nail clippers. You get great clipping, great mobility, a thin and light design, and it starts at just $99,999.99. That's a breakthrough to take our latest technology with this incredible quality of aluminum at this price. This really is the future of nail clippers.
So it's kind of fantastic.
Light and thin. Yes. Right, I think we're done.
Okay. Well, it is kind of interesting how you can make something as technology or steel or whatever, even for something like a nail clipper, really fascinating and inspiring. So getting away from the playful part again to the more serious note of this afternoon. Now we're going to talk about road mapping future architecture services for manufacturing. So how can we get more of these fantastic nail clipper Airs in Europe, the newest designs and such? So first introduction is going to be done by Silvia Castelvi. And Silvia is going to talk to us, or give us the general introduction of the later presentations. She works for Atos, where she's the manufacturing and retail head of sector, Atos' research and innovation division, and furthermore the C2Net project manager, and participates in the Road for Fame project. Sylvia, where are you? And here's your presentation.
Thanks. Okay, sorry, my presentation is not so funny. That's previous one. I will try to be very concrete and rapid through on that. Okay, Route for Fame is a CSA for designing the roadmap for future architectures and services in manufacturing. The project is started in June 2013 and finalized in next October. So we are almost on the end of the project. The consortium is very nice. We have players in IT manufacturing and also leading research centers, Steinberg's, Institute for Manufacturing from Cambridge, Fraunhofer, APA, Critical Manufacturing, and Thinking, Wireless Technology, and also Atos. This consortium is completed with a core group of experts who collaborate with us in the definition of the road mapping, consultation, reading the papers that we publish, and this core group is completed around 100, almost 100 experts from representation of the industry and academic field who participate in the workshops of designing these road mapping activities and also are involved in the deliverables on papers that we publish to review it previously to publish. As you can see, the workshops... Oh, something...
Let me just, I don't know, maybe there is some sound back there, but let's just turn that off.
Okay, we have developed for the road mapping process for workshops with experts' participation. These workshops are very intensive, working with efficient results. You can see here the proactivity with the post-its, okay, but notice work. Then we have time also for enjoy. For example, here a picture of a dinner in the Real Madrid football field, okay, where we can discuss, but in a more relaxing way. Okay, the result of this roadmap is almost finished. We have a lot of material, we have a lot of content, a huge paper regarding this future strategy, and we are in process of extract a more readable paper document to be published and communicated. Also, we have developed a catalog of business services and business opportunity. This catalog will be available at the end of this month, and then you can access to them through the webpage or so on. And at the end, we will write a nice deliverable with recommendations for future strategy, research priorities, and innovations for the European Commission, policymakers, and interested stakeholders. How has gone the process to develop this roadmap? We have started with the first phase, which is a push and pull perspective, where we have considered the key initiatives that exist in the market, also the research and innovation challenge, and of course the enabling technologies that give us the technology perspective, and this has been validated. And then we have the requirements from the industrial manufacturing, the needs, and these needs and requirements has been translated into ICT technologies. And this both perspective has been joined in the core road mapping process, which has been developed through experts' workshops in order to create, in the final stage, the research and innovation strategy document and also the roadmap for ICT and architectures and services in manufacturing and the business models. How is this road mapping? How it has gone? Okay, we have, as we commented, we have taken consideration the mega trends and also the trend related to factories of the future, CPS and IoT. You know very well which are these trends. And we have we have considered the particularities of manufacturing sectors as I was, is the efficiency and quality requirements for processes. And also we have taken consideration the digitalization, visualization, and virtualization requirements from industries, and also the demand for more individualized and high configurable products. And these also have been in consideration the smart products that has been developed and will be developed in the future. And all this field increase the complexity, not just the products, but also the process and the networks on where manufacturing is working nowadays. Through the interviews with manufacturing companies and ICT providers for manufacturing companies, we have seen that they have requirements, needs regarding cost and also flexibility, and in order to identify and anticipate in changes in the demand. We have also requirements for reduction of effort, integration of new equipments, tools that come for new technologies in ICT sector. Also necessity for traceability of these technologies on the shop floor, the monitoring, optimization of the shop floor and apply predictive maintenance. And we have seen also, okay, we have to consider also mobile devices and the interaction with the human, with the workers. And from the interviews to manufacturing, we have to say that we have seen that digitalization, especially in SMS, is a requirement coming from ICT providers, not really, in fact, from the manufacturing. We have to take into consideration in future projects or proposals. Also, we have seen that there are some key barriers. Manufacturing IT landscape today is a walled garden. We have heterogeneous manufacturing IT solutions, difficult to be implemented, and especially for SMS, sometimes it's difficult for them to access to current ICT solutions because they are complex and sometimes they are very few implementing. They have very few implementing costs. And also ICT solutions has to consider security and privacy issues. These all aspects has been considered and give us a vision of top ICT solutions that we have identified, and these ICT solutions has been considered in the roadmap process. I am not going to enter in detail. And finally, we have extracting from these trends, requirements, and ICT solutions the key recommendations for the future strategy roadmap. We can elaborate as a quick and first output of this roadmap process an orientation paper. You can access to the web page where it's available. This orientation paper gives us a view of the first strategies for research regarding scalable and cyber-physical system architectures, and also related to real-time data acquisition and analysis, the network-centric communication and collaboration between the stakeholders and machine-to-machine and human systems across the value chain, the development of ICT platforms for advanced supply chain decision, and modeling the virtualization enterprise. All of these research topics are supported by cross-cutting challenges such as interoperability and standardization, semantic mechanics, socio-technical issues, training and educational, and also cybersecurity. The recommendations that we have elaborated and we have managing at this moment could be grouped in several key issues, which are integration, data and information, machine learning and adaptive systems, multidisciplinary modeling, security and privacy, and at the end, demonstration and education. The paper, the roadmap will be available at the end of October when the project finishes. And another chapter, very important in this road mapping process, is the business opportunities, because these business opportunities are in the top of this architecture and services, and brings the commercialization, the economical part of the technology. We have investigated the current business in manufacturing sector, and we have identified around 100 business models that we can cluster. We have clustered in 10 categories. These are the 10 categories that we have identified, and these are prioritized through a workshop with contribution of experts. And we can see that there are some business models, such as networking, that are priorities from trend-driven perspective, but also priorities, from the ACT solutions, okay? Time has finished. This we have elaborated more in a business workshop, which was celebrated in Madrid, and at the end, this converges in these themes of the road mapping process that we have commented. And you have more information in the webpage. Thank you.
Thank you very much. It's not working yet. Continuing with the perspective from the European context, ICT factories of the future, Maurizio. Oh, there you are. And Maurizio is the chairman of EFRA, vice president operations at Prima Industrie. Is that correct?
Correct.
You know that the Dutch word for Prima is fine. So it's fine industries.
Perfect. Perfect. Exactly that. It's a German word. It's an Italian company with a German adjective on it. But I'm not here to speak about my company. I'm here to speak about manufacturing. And I should be very good here in this context in ICT, but I'm not, and so I have to try to switch the presentation to mine. Thanks, Silvia.
That should be here. ¿Es esta, no? Yes.
Thanks a lot. This is proving that I'm a mechanical engineer and not an electronic or information technology engineer. Okay, let me comment something about manufacturing. We know how manufacturing important is, okay? We are all working for that, and so we are proud of it. But evolution in last year has not been so positive for European manufacturing. Looking at the 15 manufacturers countries, looking at their gross added value, we have seen that China passed from 7th ranking in 1980 to 2nd ranking in 2010, and now is in the 1st place. And United States moved from 1 to 2nd. Still, European manufacturers has a role there, an important one. Germany, Italy are still in the 1st position of this ranking. But other country has grown a lot. Looking at Korea, Korea was not in the first 15 countries in 180. So the first question is how much ICT played a role in this? We know that there are a lot of effects which are justifying these changes. The first one is that manufacturing is going closer to the consumption. That means that a country with 1.5 billion people will have, for sure, more chances than Europe with 500,000. But there are also other effects. And if we look, for example, at the position of Korea, Korea is starting in the late 80s a policy towards ICT for manufacturing. Samsung grew a lot, and they changed completely their ranking in the world. So for sure, among all other factors, also ICT has a role here. And the question that we have to answer is, do we have a chance to play a role in the first 2 or 3? Do we have a chance, before we were speaking about iPhone, do we have a chance between Apple and Google on one side and Samsung on the other one? We think yes. I have been, for example, quite impressed about this new phone that I don't know if you know, it's called Fairphone. It's produced in Holland and is done with ethical production, using rare earths which are not coming from mines controlled by war bosses, manufactured by employees with rights. So it's not mandatory that you have to produce your tablet in Foxconn. There is a third way. So this is the role we have all together. And Mr. Juncker has pointed out that the goal of 20% of GDP for manufacturing is the priority of the Commission, is the priority of the European industries, universities, and the research centers. And yeah, we are to try to do that. Will not be easy. Will not be easy, because also if you look at this diagram and you add approximately 50% going back to 2008 from what we are today, you don't reach 20%, because 15% from the actual value plus 15% make 18%. So we have to do something extraordinary. It's not a battle that we can win just with ordinary means. And part of this is for sure the good use of the budget of Horizon 2020 for manufacturing. It's 1.15 billion euro that we have to use well. And I think that I4MS is a very good demonstration how you have well used a budget which is not enormous. It's a limited budget, but from what we have seen today, we have seen a lot of very positive results, also with limited amount of public investments. So the private side is making its part here. Looking at the wider scenario of Factory of the Future, not only at the I4MS, we have 180 projects which are, most of them are already finished and some are still in process. We involve more than 1,000 organizations, more than 200 SMEs. And so we come to the second important point of the I4MS. The final S is final but is crucial. Why is crucial? Because most of the people in Europe working in manufacturing are working in SMEs. And you see from this diagram, it's quite different from country to country, but looking at the average, you immediately understand how SMEs important are. And probably if you will include also mid-cap, you will find the vast majority of people are working in SMEs and mid-cap. And then we need policies, clever policies, to have these SMEs playing an important role in the world economy. Because the battle is not played in small countries, is not played here, is played all over the world. And this program has done a lot, and has done a lot probably in the right way. focusing on sectors with high added value and high expected growth. Today I've heard that laser, for example, sector, where Lashare is working and Apollo are working, is expected to grow from 4 to 6, 7%. Is not completely true, because this is the average value. The average value including the actual lasers, the actual technology like the gas lasers. But if you look at the solid-state lasers, fiber lasers, for example, the CAGR is in the range of 17–18%. If you look at the high-power diodes, the expected growth is from 15 to 20%. So we need to focus on high added value, on new technologies. Cloud is another key point, so Cloudflow and the other projects are focusing, Fortissimo are focusing there. Is not only a technology trend, because cloud is an answer to the need of the SMEs to have affordable tools, ICT tools. There are a lot of researches about SMEs, how skeptical the SMEs are in adopting ICT tools. Very expensive, difficult to have different tools communicating among them, very difficult to understand which is the return of the investment. So the cloud, then the services associated to the cloud, which will allow SMEs to have access to technology at a reasonable cost, is another important answer. And last but not least, robotics is another technology where we have to focus, because robotics will come in manufacturing more and more through collaborative robots, a new generation of robots. It's not the automation of the 90s, where we have to make millions of pieces, one equal to the other. It's a completely different scenario, valid also for small quantities. And this is the role we are playing. This is the role you are playing. We have developed this strategic agenda. We are in a phase to review it, because world is changing quickly, and also our strategy has to follow the changes. We will have in November a workshop for EFRA to develop a new view of the strategic agenda, and the contribution of all the stakeholders, of all of you, is highly appreciated for that. Okay, because the factories of the future, like the other PPPs of FP7, are sector focused, and then all the different technologies are coming inside that. So the cloud, we already said, the cyber physical systems, the augmented reality, the big data, the Internet of Things, all these new technology will play a role in the factories of the future. This is something that you already find in our strategic agenda, but you will find more and more in the new edition. Okay, let's go quickly to the end. Yesterday we had here our General Assembly. We reached 200 members, active members, trying to contribute at the best to the evolution of the manufacturing in Europe. And we will continue to do what we have to do, to work to promote research, participation, partnership in manufacturing. Let me quickly conclude that we are also an ICT-focused PPP, because all the knowledge that we are generating is in our portal. So we try to do our best also for that, also if I'm a mechanical engineer. And looking forward, we will continue to support the Factory of the Future. I have already said that we are undertaking the revision of the Factory of the Future 2020 roadmap, and we will have also some other events which will help us to do that. The Info Days on the 16th of October here in Brussels, the ICT 2015 in Lisbon, and ManuFuture annual meeting in 23rd and 24th of October. Or you are welcome to participate, and you are welcome to contribute to the vision of a new manufacturing, of a new way of thinking manufacturing and approaching it. Thank you a lot. I'm finished. On time.
Thank you very much. While Katrien is getting ready, next speaker, Katrien Wiekert, Director of Automotive Industry Solutions from Siemens for her next presentation. Thank you for the update on EFRA. I know that having had the different talks in the coffee breaks and such, one of the elements in your slides was the links to the national and regional initiatives and such. And I think there's quite a strong interest for that, because you've got the usual suspect, almost say the choir in Europe. We all sing the Seventh of Beethoven and such, and we all grab into the European pot of money. But there's also an initiative. What about the entrepreneurs that you're not reaching? Whether it's the cheese manufacturer of this morning, or let's say maybe some carpenter in deep down in Poland or such. How can you get to them? Not today, but tomorrow. And what are the instruments that really help leverage it there? Because there are so many unique assets we have here in Europe, so much experience and research and insight. How can we spread that word beyond the choir? So that's it. Katrien, the floor is yours.
Thanks. So my name is Katrien Wiekert. I am from Siemens, but from the PLM side. And my personal background is really test and simulation. So when I was preparing for this presentation, for which we received an invitation from the Commission, I was thinking, how can I indeed position, should I say, simulation innovation and technology innovation and digitization in a context of, let's say, new challenges that the automotive industry has to face? Because also, the automotive industry, even though it is a very mature business, as you all know, and it was named a couple of times this morning, they are in a major change. And they have been in a major change since quite a while. And these changes relate really to business transformations that they also have to go through. They face an enormous competition, an enormous globalization. They need to deliver basically innovative products in specific markets with an enormous flexibility. And it really has challenged a lot the engineering side as well as the manufacturing side. And so a couple of the ideas that I wanted to bring forward here, one of the transformations, for instance, has been, of course, the whole eco-green. We've been talking about green. The whole eco drive has been an enormous transformation, electrification and hybridization in the automotive industry, but also now the next stage is now the autonomous vehicle. You know, today there is already active safety systems in the vehicles, but it goes further and further into this direction. Second is also in the manufacturing side, of course, there is innovation to happen and change ideas both on efficiency side, but also on modularity side and flexibility in terms of the manufacturing lines. And then there is also a lot of thinking about business model innovation. And business model innovation, it has been mentioned a couple of times already also today, has to do with big data and how does it apply to the automotive industry. The point is that there is a lot of data available from all of the control systems on the vehicles, and the engineering communities in the automotive industry are really thinking about how to get value out of these data for services, and that is a whole domain of change as well. And what I want to just talk a bit about is here, how does that affect the need for simulation and testing basically in the engineering departments to start with. We don't need to convince the automotive industry to use simulation. Simulation is a given since a long time. We don't need to convince them of HPC. It is there since a long time. But what is currently happening in the challenges of all of these innovations that I was just mentioning is that indeed they need to rethink and refocus the effort of simulation towards the new challenges. And therefore there is quite a shift ongoing in simulation technology from traditional 3D technology also into the functional system simulation, which supports mechatronic system development. And that is really an area of, shall I say, change ongoing. And here I give a couple of examples of that. If you develop an active safety system and an autonomous, if you think about autonomous vehicle and really safety systems that really are dependent on the vehicles in front of you, that are dependent on which conditions you're driving, etc., people in the engineering communities really need to be able to simulate those instances. And that is where real-time simulation really plays a role, combination of 3D and 1D type of capability to support the many road scenarios, basically, that are really happening. And you see a lot of investment in, shall I say, digitization in support of models, in support of, let's say, evaluation of road traffic and environment simulation during the engineering side. And the second example here is about shift feel. Yeah? Is how do you really, with the controls in your system, how do you assess in an earlier phase in development, how do you assess how that shift feels? And there is also where model in the loop really plays a role. Another example where there has been a major change is the energy management. I was mentioning before, energy management means that the automotive industry needs to study many different hybrid versions, many different electrification versions. But it's not only about the powertrain, it's also about the control side, and it is also about the integration of all of these systems together. And the integration of all of these systems together makes that they need a system modeling approach to put in place. And that is also challenging for the automotive industry because they are organized in very specific departments. The cooling systems, the HVAC systems, the tire systems, the suspension system, the transmission systems, the powertrain systems. And they all need to come together into this energy management model. And that is also change that is needed. It was mentioned by one of the previous speakers, composites. Composites is also a big, let's say, innovation ongoing in the automotive industry today. And where it relates to composites, there is, of course, a lot of cumulated experience in the aeronautic industry, but it is not yet there in the automotive industry. And so it's a major thinking of change also ongoing is how to adapt the engineering processes and the manufacturing processes in order to address this lightweight challenge in the automotive industry. The cost of manufacturing is still very prohibitive, so you will see a direction of mixed materials going on. Meanwhile, the automotive industry is also innovating in terms of which simulation support is needed to couple the manufacturing aspects of composite development with the performance simulation side. And it's a very interesting domain going forward. But also in the manufacturing production, there is need for simulation because of, shall I say, the need to, when you design factory floors or you adapt factory floors to certain smaller production lines, to certain combinations of productions and so on, there is a lot of logistical planning needed. Now, if you need to do that planning only, shall I say, by meeting, it is very, very difficult. And that's also why in manufacturing engineering you see a lot of simulation being used and being wanted, basically, in the automotive industry. And it is about building really a digital twin of the real production cycle. And it is about planning, it is about factory simulation, but it is also about simulation to support machine optimization. And so one of the examples here is about process, logistics optimization. So it's about energy studies on the total production line. It is about human in the loop in this manufacturing process, human in the loop, and doing logistics studies on how, what are the most optimal configurations, basically, of the machines, etc., etc. But it is also about more in-depth studies of particular of the machining parts, like you see here a study, more in-detail study in simulation of robotic structure, where of course the whole automation and plays a very, very important role. But also to the right side of the picture, you see that also the manufacturing industry is really interested in intelligent models to support performance of machines to have better production throughput rate. So simulation plays an important role also in optimizing for these things. And then also there is the notion of virtual commissioning of manufacturing. Virtual commissioning is really checking the PLC controllers basically of the production lines, but not on the production line itself, but in the lab, in a physical virtual context. And it is very similar to controls validation basically in the engineering side. So you combine a virtual model of the factory simulation with the real controllers, and you test the control performance basically in combination with the virtual model, and as such you allow much more modularity. And then the last topic is just a couple of examples on transforming the business landscape. When I was saying with all of the controls on the vehicles, there is a lot of information that can be drawn from these controllers. Today, it's a technical term, the CAN bus. Today, on the CAN bus of the vehicle, there is an enormous amount of information on braking, start-stop scenarios, you move through the traffic, you accelerate, you decelerate, you brake, etc., etc. An enormous amount of data can be posted on the cloud. There is potential for that. And that's also why we see business innovation ideas, and I give here this little example where indeed people pick up the data from, for instance, a truck fleet and bring those data back into the operators of the truck organizations to interpret the driver fuel economy, the best driving strategies, etc., etc. So it's a service model for business innovation. But you also see in the engineering side that there is interest in big data in order to do very specific data analytics and very specific data mining technology on these type of data to take from that load scenarios and to put them also back into the simulation. If you develop a start-stop system and the transmission is not really made such that it can really withstand all of the start-stops that you have during your scenario, it's really a problem. And there are actual problems about that in the market. And it is a completely new type of loading that OEMs need to consider. And also...
Can you wrap up?
Yeah, I'm finished. This last example has also to do with simulation in support of business innovation. It's an example where indeed the electrical vehicle and the battery storage ID are really connected to, shall I say, smart grid and to loading and disloading, putting your car basically as one of the electrical elements into a total system. That's also where OEMs are taking some future studies to see what would be the effect, what does it mean in terms of scenarios, etc., etc., and also for that they use simulation. So simulation is not only in support of standard development, but is also in support of innovative ideas in terms of business transformation. That wraps it up for me. So a couple of messages is that also in the automotive industry, business transformation implies change. They need to look for new solutions. There is a lot of effort in digital twin engineering and in manufacturing. System level approach is very important, but also, of course, and that's the challenge of the automotive industry as they are so large, they need to work on process and deployment methodology to have consistent product models throughout the life cycle, both at the engineering side and at the manufacturing side. That summarizes my presentation here. Thank you.
Thank you. And the final presentation coming up is from Adrien Zitetti, Senior Strategy Analyst at Dassault Systems, responsible for the manufacturing domain.
Good afternoon. Do you find it? Yeah, yes. I'm not a mechanical engineer, so maybe I can do it.
Okay. Oh. Okay.
We do. Thank you very much. So I'm very glad to be here. And I have to say that I'm very impressed with what I saw this morning. Not only for the beer, stuff, but also all the robotic challenges, the customized shoes. All these are examples of SMEs. I think there's more than 200 starting to get into the race that we are in at the moment. This race is about a big transformation. And as you introduced the show, I was going to say this morning, you said it's not just about technology, and I think you are completely right. If there's one message I'd like you to keep from my presentation is that technology is there. It's not the problem anymore. Of course, we have tons of things you can improve. You can jump on me with bugs that you have in Katia, but it's there. What is not there yet is adoption. And it reminds me of 15 years ago, the beginning of my career, when IBM was explaining about e-commerce. And you had this Chinese lady selling sushi, not sushis in China, but dim sum on the street saying, I'm going to open a website and I'm going to sell dim sum all over the world. And everybody was laughing. And 15 years later, what's happening? Last week, I had to change a bulb in my house, but a very special one I could not find in my local store. I went on the website, I found one very quickly, cheaper, got them in 24 hours. So 15 years ago, it looked like something crazy. And today, we have e-commerce everywhere. This is what we need to achieve for manufacturing. Today in manufacturing, everybody, especially in SMEs, is speaking about physical world of manufacturing. We want to turn them into this idea that physical is as important as digital. Sorry, that was a long introduction, but I think it's a key message. To illustrate that, the fact that the technology is ready, I just want to give you an overview of a recent presentation we've made to show how we have put all our engineers to build all the products we have into the same platform so that you can have a journey from the design, and you see, for instance, you can do design perhaps over the cloud, perhaps on your local tablet, but everybody can work when they think is the right time to work, collaborate more easily, and everything is shared in a single platform. That's the key idea. The next seconds of this demo, you are going to see that the next door in your office or the next building or the next town or the next country, someone else will take your model and will work on the validation of the physics. So here, for instance, with this machine, we are validating that when you rotate this thing for several thousand hours, how fast the attrition of the springs are going to happen. And this is something you do on the same platform. Now, a few seconds later, you'll see that it moves to manufacturing. The idea is still digital continuity. My friends from Germany, I've seen this word in Industry 4.0 everywhere, Durchgängigkeit. That's everywhere. You can go from design, engineering, manufacturing, and back. That's on a single platform. That does exist today. Okay. Message is there. So why today does that? So sorry, I'd rather talk to you as colleagues. Why? How could you explain that to your customers, to your partners? Why is manufacturing important? What should CEOs care about manufacturing today and maybe not more than yesterday? They want to improve their capital and their expenditure. This is where they usually spend the most. They want to make an impact on their customer. They don't want to be displaced by their competitors. Manufacturing and the services that goes with it are usually what impacts the most the customers. They want to make sure that their employees have the right skills and that they are able to turn them into the right skill set all over the time. And this is usually where they have the most employees in manufacturing, 10 times more than in design, or even more. And typically, this is the most hardest thing to change in a company, because this is rooted into this physical world. And this is really why the digital approach will make a change. So the race today is not anymore about productivity. It's about how you turn this system with your employees and your production system, the physical and the virtual one, into a constant transformation that stitch with the market, that beats your competition, and that provide all the services that your customers are expecting. And I have 4 messages. So the first one is, this transformation of your physical business models cannot happen without a digital transformation. And we have a proof of that. I can provide you the link. There is an MIT analysis with Capgemini, maybe you were part of that proved how to transform yourself efficiently, you need both transformation of your business model and digitalization of your business model. So that's, for me, that's the best proof at the moment that we show at every conference, because I think it's really there right on the point. The way we put that in our system is that we have explained that the spread of your digital transformation is going to be through 6 layers. And I'm very happy to find in the recent document from Industry 4.0 that 4.0 that it's part of their new architecture model, these layers. It's not exactly the same 6, but there's an IEC standardization work, so that you have a virtual model that's organized by layers from the product, interface, resource, station, and so on. And I hope it will fit also with the work you're doing on Road for Fame. I would be very happy to share with you what we have behind that. The other aspect, to make your transformation quicker, so that the other axis of the Capgemini diagram, is that you need to implement a Deming wheel by doing plan, do, check, act on a regular basis. This is a step-by-step improvement. And this is the reason why we organize all our applications around a compass, where you are going to plan, you imagine something, then you are going to execute it in the real world, then you are going to collect the data and check it works, learn from that, and then collaborate again, plan again, and so on. And through this cycle, with all the applications on the same platform, you can accelerate your change. And with the digital model that everybody shares, the same referential, you accelerate the change also. So I think this is the tool we propose to be in the top right quadrant of the Capgemini MIT analysis. That is, where are the best digital transformation examples? Second message, the first one was you need digital to transform. The second one is industrial excellence. To do industrial excellence in manufacturing, you need to do 3 things. You need to be able to plan efficiently, you need to be able to execute efficiently what you have planned, and you need to be able to optimize constantly your plan and your execution. And this is what we provide through the different products we have. I'm not going to go in the detail. We do that with many customers, but there's one big caveat. So this slide is the marketing slide for the presentation, explaining we do that with many companies, but guess what? They are all big companies. So how do we move forward with SMEs? That's the challenge of today. This is my third message, digital collaboration. What has changed from the past is that previously collaboration was a kind of crossword. At least in my company some years ago, speaking about a collaboration project, you had to be very sure you wanted to do it because management would tell you, why do you want to collaborate? Today, there are 2 big trends I've noticed. One is that there is new technology everywhere in manufacturing, and new technology is disrupting everything, and it costs a lot. So people are getting together because alone they cannot sustain or they may make wrong choices. The second, even worse trend is that there are players like Uber in the transportation system appearing in manufacturing. So I have 2 examples here. I have Tesla and Staubli. Staubli is displacing some large robotics players because they have some nice, precise robots. Tesla is displacing some nice electric car players because they have this nice car. And every large player is wondering, oh, what's going on? How should I avoid someone to jump on my market and replace me? So they are assembling into platforms. And for me, EFRA is the largest platform that exists for the moment in the world. Soon in competition with China, because China just raised $8 billion program for China, Made in China 2025. And I think this is going to be a challenge to make sure that we keep the pace. So this collaboration will happen, and it happens, we have noticed, around 12 subjects. I'm not going to detail them all because we don't have time, but I'm happy to share with you the ideas we have around the different subjects, and you see how it maps with the different levels of virtual model. It should be a way to align all the subjects, and to give just one example, laser application that I saw this morning, we would be very happy to work with laser companies to have a digital version of their process that we can put in our libraries so that customers can imagine how they could apply that in their own world. Of course, it requires maybe pre-processing, post-processing, new quality processes and so on, but the virtual model we want to build is a virtual model that encompasses all these aspects. That's just one example, and we could be very long on that slide, and we don't have time. So to finish, I'm jumping ahead. The last thing is people-centric factory. Don't believe that the factory of the future is a fully automated factory. The people are bringing the agility we need. The key word in Industry 4.0 is flexibility, and flexibility comes from people. So with this nice virtual model, people will have the ability to make decisions on the fly, pilot their processes, decide when something unexpected happens, and it's really them that are there. It's really the people that are bringing this agility in the company. But today they don't have the right skills. That's a problem. And we are making a project with the EFRA and European Commission, which is about analyzing how we can attract more young talents to manufacturing. We have identified the different reasons why manufacturing has a bad image and we lack the right skills in manufacturing, at least the young people. And we have identified that US plus Europe, we have probably 1 million jobs that are waiting for people with the right skills. So how can we solve that? We are just at the beginning of creating a plan for that, but we have made some experiences, and here I'm sharing one with you that we recently delivered without sound. So I said I'm able to do it, now I need to do it.
This is a funded project aiming to increase teenagers' interest for manufacturing industries and careers. Gathering universities and companies in many European countries, ManuSkills consists in creating innovative experiences based on new pedagogical approaches to promote industrial engineering among young people. Among the experiences developed is Dassault Systèmes Skateboard Experience, which gives students the opportunity to visualize, manipulate and assemble 3D workpieces of a skateboard in order to produce its documentation. Based on 3D experience platform, this hands-on experience enables students to consider all the possibilities offered by Dassault Systèmes professional software solutions. Through this learning activity, supervised by professionals, teenagers explore by doing the key concepts of manufacturing. Students handle tasks related to manufacturing process planning, such as establishing the skateboard bill of materials, assigning each part to the corresponding workstation, or providing the necessary documentation. This step-by-step documented learning activity reduces students' fear of failure in sciences, technology, engineering and math fields. Working in a safe 3D environment enables students to try and fail without affecting the real product. Co-designed by engineers and educational experts, this pedagogical scenario focuses on a popular product to increase students' interest and implication. The skills developed through this experience may eventually be reused in a real-life context.
Okay. So, one word of conclusion. SMEs. We are really interested to discover more about the projects you make and discuss with you about our possible involvement. We are really happy also to discuss with SME in the IT field that are providing solutions for manufacturing, because we are recruiting partners for our ecosystem. And we are also very interested if you are a specialist in a hardware or a new process, because we'd like to discuss with you how we can have a virtual model of this process in our libraries.
Thank you very much. Now, we'll have time this afternoon for more of a discussions with the panelists, but any questions from the audience so far on the three presentations we just had? Otherwise, you know that actually at the biological level, the human body's production process is such that after exactly 46 minutes and 30 seconds, a certain breakdown of lunch happens that you are almost doomed to fall asleep right now. So that's why shortly after the lunch break, we have planned a coffee break. The networking part, forget about that. You're just there to get caffeine, wake up, and get back here. You got 7.5 minutes for that, and I'll see you back here then. Thank you.